with elimination substitution problems?
Yes.
Like with numbers or like
Not the RS or not those three, not those yet, but just where you have the problems that look like this. Okay, and they say solve by elimination substitution. What we're going to do today, if you remember when I first introduced that and we had N with a subscript of B and N with a subscript of Q or something like that, and I said dimes and quarters is what it was making reference to. This lesson, solving is going to be something you already know. You're going to do elimination substitution. The only thing new is that you got to set up the equation. And that's where the confusing part's going to come in. But you have two things. If I dig out all the change in my pocket, which I have none, but if I were to take change out of my pocket, we want to separate the quarters and the nickels and the dimes, whatever. We want to separate them, and I could do two things with them. I could tell you how much money I had, or I could tell you how many coins I have. Those are the two things. So if you can remember, number of coins and then money, the two types of equations you have to write. Then it's elimination substitution. So if we look at this example, Bill had 50 nickels and dimes. What's that right there? How many coins, right? So I need to write a number equation, counting how many coins I have. Well, I have nickels and dimes. Just the coins is how much? 50. I have 50 coins in my pocket. Now, if I continue reading this, so Bill had 50 nickels and dimes. Then we have a money situation, and it's this value. What is the value of it? $4. So if I have value, then I got to put coefficients with nickels and dimes. How much are the nickels worth? 5 cents. Each nickel is 5 cents, right? So I'd have to put 5 cents times however many nickels I have would tell me how much. You guys have never settled up in the concession stands before. So you haven't had to count the money. I don't know why they don't trust students counting money. But you've never had to count the money at the end. What you would do is you would count how many coins you have and then take it times 5 cents, possibly. Then again, some of you might go 5, 10, 15, 20, 25, 30. Dimes, how much are dimes worth? 10 cents. Now keep in mind, I didn't put this as this, because who likes decimals? If we don't like decimals, but we got to have unit agreements. I don't want to use that. I can't have this as cents and say that it's equal to 4. It has to be 400 because it all has to be in terms of cents. So I would have to write that as 400. Do you see where those two equations come from? Now it's something you've done before. How would you solve that? Elimination substitution. I'm guessing you would use elimination. Would you multiply by 10 or by 5? Right? I always like 10 because it's an easy number to multiply by. But we can do 5. I'm just going to show you 10 real quick. I'll show you why 10 is so easy. Because now this equation right here becomes what? Negative 10n minus 10d equals negative 500, right? Now what happens? These cancel, and right here you are left with negative 100. Over here you are left with negative 5n. I didn't use subscript. I could change this to n sub n and n sub d. Do you like that? No. So I'm just going to leave it as n's and d's. How many nickels do you have? You have 20 nickels. How many dimes would you have? 30, because how many total coins do you have? 50. You think about it. Nickels, if I have 20 of them, how much money is that? $1. If I have 30 dimes, how much money is that? $3, and you have a total of $4. You could guess and check if you really wanted to. You could figure out if I had equal amounts of both, something like that. But it can be an elimination substitution problem. This one. Same thing, except for all of a sudden now I have something, currency, called pence. So we want to make it sound, oh, this is a confusing problem. I got pence instead of nickels and dimes or something like that. If we look at it, instead of nickels and dimes right now, I'm not talking about how many coins I have. I'm talking about how much fish I have. I either have codfish or what? Mussels. So I know that if I talk about how many codfish and how many mussels I have, how many total things did I buy? 26 items. She bought 26 items. How much money did you spend? 86 pence. But what else do I know? Codfish are 6 pence and mussels are 1 pence. How do you write that equation? 6c plus 1m equals 86. How do you solve that? Hey, elimination substitution, I would just negate one of them. So I'm going to take the top one times -1. And if I take the top one times -1, I get negative c minus m equals negative 26. You see how I just write that down there? All right, so 5c equals, if you subtract, you end up with 60. So how many codfish did you buy? 12. If you spend a total, or if you bought a total of 26, how many mussels did you buy? 14. Do you see the two equations you have to write? And then it's the elimination substitution. Want to try this one on your own?
Oh, I usually do it.
Yes. One equation you had. Now be careful when you read that. Sometimes people see that as 80 nickels. You don't have 80 nickels. You have 80 nickels and dimes. So nickels plus dimes equals 80. And then we go to the money equation. It's $6.50. So nickels are 5 cents, dimes are 10 cents, and I have 650 cents. So from there, you're going to do elimination substitution, and I believe you're telling me you have 50 dimes and 30 nickels. Is that correct? 50 dimes is how much? $5. 30 nickels is how much? $1.50. Is that total of $6.50? Yep. Okay with that? Yeah. All right. Great. You want to try a pence one now? Okay, your two equations. You bought 35 flowers, so you have roses and daffodils that you're purchasing, and you spend it or buy a total of 35 of them. Roses are 12 cents or pence each, and daffodils are 4 pence each, and you spent a total of 300 pence. Sorry, I don't know the equivalency to U.S. currency right now, but 300 sounds like a lot. Okay, the elimination substitution, tell me what you came up with. Roses are, did he buy 20 roses?
Yeah.
20 roses, and are we getting 15 daffodils then? There we go. 15 times 4 is 60 pence in daffodils. 20 times 12 is 240 pence in roses. Total of 300 pence. That's just checking it. That's not saying that's what you got to do.
That's weird. I looked up 10 and there's 100 pence and 1 pound. I gotta come up with kind of.
Are we good with this?
Yeah.
All right, the next thing that we have to talk about, do you remember day before yesterday we talked about similar triangles? What did you know about their sides?
The angles were equal.
Angles are all equal and the sides are proportional. They are proportional to each other in similar triangles. The only thing, if you go back to the very beginning when I told you what the lesson was going to cover, it had something that looked like this. A implies A. It looks confusing. Do you know what this says right here? It looks confusing. It just says if two angles in one triangle equal two angles in another triangle, what do you know about the third angle? It's going to be the same. So if I told you that this was 30 degrees and this was 50 degrees and this is 30 degrees and this is 50 degrees, that's the AA. Two angles in one triangle equal two angles of another triangle. What does that mean? That means that the third angles have to be equal, right? Because the sum of the angles of a triangle is 180 degrees. That's all it means. They tried to make it complicated. But when you go to write a proof next year, that shorthand is going to be really nice. Shorthand is going to be really nice. Let me see. Okay, I'm good to erase. That's all that's talking about. Now what they're going to, oh, I thought I was good to erase, but I guess not. Okay, one. And sometimes I think it gets confusing when you start drawing all these bars and marks in there, tick marks. So I put dots sometimes. Here's all the, this is the new problem off of it, is this right here. Is that any different than what you worked with yesterday? Except for the orientation of it, that's the only thing that's different. I'm going to mark these third sides, or those third angles, I should say, are going to be equal, right? We have these two angles congruent to each other. These two angles are congruent. So that means that those third angles are equal. If I look at it, what are these side lengths right here? Small triangle, 4, 5, and 7. We're just going to set up our proportion because the sides are proportional. Those are similar triangles. 4. Do you see what 4 is between the single and the double tick mark? What's it correspond to? 6. So I'm going to put that there. What does 5 correspond to? X. It's between the double tick mark and the dot. Between the double and the dot is X. And Y corresponds to? Oh, 7 corresponds to Y. I said that wrong. So what is X equal to? Oh, one thing you could do if you wanted to is you could just reduce this one right here to what? 2/3. Now what is X? X is 15/2. I think that's easier than saying it's 30/4 and then trying to reduce the fraction. If you can reduce one fraction to begin with and then cross multiply and divide, you have smaller numbers. What's Y equal to? 21/2. Cross multiply and divide, and you have X and Y. So new material, not so much. It's just that your triangles aren't oriented in the same position now. Really look for those tick marks to get corresponding sides in the same position. Question? All right, let's look at another one. Do you want to try this one on your own?
Yeah.
All right. You only have one angle marked. What are these angles? The same. Do you know why? What do we call those angles? They're congruent because they have the same measure, but how do I know they have the same measure? They're referred to as vertical angles. Vertical angles. Supplementary is what? Maybe you weren't going to say supplementary. I thought you were. Supplementary are two angles that what? Equal 180. They equal 180. Remember when you write supplement, I think some of you are remembering it like that. It's 180 degrees. Complement is what? 90 degrees. You complement the smaller figure. Did you get your proportion?
Yes.
You have a 3, 4, 5 triangle? It means it's a right angle or a right triangle, right? 3, 4, 5 triangle, right triangle. So I think you're going to get fractions involved probably. All right. I don't know where you want to start. If you go with the marked angles, 4 corresponds to what? Y. 3 corresponds to 5. Now in your book, they might talk about a certain scale factor. I don't worry about the scale factor. I can talk to you later about that. But I think that if this is a confusing method to you, I will show you a scale factor. And then what is 5 here corresponds to x in your other one. So what is x equal to? Cross multiply and divide, and you get 25 over 3. What is y equal to? 20 over 3. Good? Tomorrow, I'm gone. What are you going to work on? Lesson 19. Due when? Monday. Monday I will take any questions.